In our previous presentation, we touched on why systematic integration is the future of AI-assisted development. Today I want to show you exactly what that process looks like, step by step. We built a working Telegram coffee bot, and I'll walk you through the approach that made reliable AI assistance possible. This is about demonstrating the process that enables conversational coding to work reliably. Not random successes, but consistent, controlled results. We started with essentially nothing: an empty docs folder, basic project structure, and a clear goal to build a Telegram coffee bot. The repo is on GitHub, so feel free to pause and inspect the docs and the code. The crucial insight is that we didn't start by opening up Cursor or Rocode and asking AI to generate code. We started by creating the foundation documentation that would guide all AI interactions. Most people jump straight into conversational coding and wonder why they get inconsistent results. We're going to show you the preparation that makes the difference. Let me be honest about the alternative approach. Before building this with proper preparation, I tried the typical developer approach, a single prompt asking AI to build the entire Telegram coffee bot. I spent hours prompting in circles, burned through over $30 in API costs, and still couldn't get a system that would deploy properly or handle all the edge cases correctly. It's ultimately a lottery. Sometimes single prompt approaches work, often they don't. The frustrating part is that when they fail, you learn nothing repeatable about why they failed or how to make them work consistently. But the random approach did reveal several edge cases that weren't covered in my initial documentation, which ironically proved why comprehensive documentation matters. Let me show you the process flow that actually works. You start with an empty docs folder, then create foundation documents including user scenarios, data models, implementation tasks, and developer guidelines. Next, you set up progress tracking with checkboxes that have verification requirements. Then you work task by task. Take task 1, use AI implementation with full context, verify the results thoroughly, answer quiz questions to ensure understanding, and only then check the progress box. You repeat this for task 2, task 3, and so on, with each step building on verified previous steps. The result is a working system plus comprehensive documentation that enables future maintenance and expansion. Each step is verifiable and repeatable, not random. Step 1 was creating foundation documents before writing any code. We created user-scenarios.md with specific user stories like, as a customer, I want to order coffee using natural language so I can place orders quickly. We built data model.md with exact TypeScript interfaces for business objects. We structured implementation tasks, MD breaking work, into task 1, bot setup, task 2, natural language parsing, task 3. We established developer guidelines.md with specific coding standards like use math, Chartor, for currency precision. This isn't busy work. This documentation becomes the context that enables AI to generate code fitting your specific requirements instead of generic solutions. Let me show you a specific example of how documentation drives implementation. Here's the actual user story we wrote. As a customer, I want to order coffee using natural language so I can place orders quickly. The acceptance criteria specified: 1 large cappuccino with oat milk should parse correctly, cap abbreviation should match cappuccino, missing size should default to medium, unknown items should return helpful errors with the menu. This specific documentation drove the AI to implement fuzzy string matching using Levenstein distance, create alias dictionaries for common abbreviations, and build helpful error messages. Without this context, AI would have generated basic string matching that breaks with real user input. Step 2 was setting up our control mechanism through implementation progress.md. This document lists every task. Task 1, Telegram bot setup and message handling. Task 2, natural language order parsing. Task 3, order calculation and response formatting. But here's the key. Each checkbox has 3 requirements: working code, verified functionality, and developer understanding. This becomes your quality gate. You can't check a box until you've tested the functionality, verified it works correctly, and answered quiz questions proving you understand the implementation well enough to maintain it. Step 3 is the actual development flow, where preparation pays off. You take task 1 from your progress document, Telegram bot setup and message handling. You provide your AI tool with all the context documentation. The AI generates bot DTs with proper Telegraf integration following your specifications. You verify the webhook setup works correctly by testing actual message handling. Then you answer quiz questions about the implementation. Only after completing verification and understanding do you move to the next task. This prevents building on top of unverified or misunderstood code, which is how technical debt accumulates in AI-assisted projects. The quiz concept is essential for maintaining control. Here's a real example from our Task 1 implementation. Question: why do we set webhook reply false in Telegraf? Answer: prevent session conflicts when using webhooks with middleware. For Task 3, how do we prevent floating point precision errors in currency calculations? Answer: use math around amount 100 to round to the nearest cent. If you can't answer these questions, you don't understand the code well enough to maintain it. The quiz ensures you comprehend the technical decisions, not just that the code works initially. Let me address why this level of preparation matters. Here's a common pattern many developers experience with conversational AI coding. You start with what seems like a simple change. Hit one minor bug, try to fix it, but create new issues, then fall into an endless series of random rewrites until you eventually give up or start completely over. I've experienced this myself. What should be a 5-minute fix turns into hours of debugging AI-generated patches that don't understand the broader context. For bigger systems, having a solid foundation becomes absolutely essential. Random fixes compound into unmaintainable complexity that eventually forces complete rewrites. The structured approach prevents this by ensuring each step is verified and understood before building on top of it. When issues arise, you have clear documentation and verification checklists to debug methodically instead of randomly. Here's the reality. LMS make the same mistakes human developers do. Our implementation progress.md documents the actual issues we encountered. Webhook not receiving messages required adding an express server setup. Commands not working was caused by wrong middleware registration order, a classic Telegraf mistake, or so Claude tells me. Bot not passing orders needed completing the fuzzy matching logic implementation. These aren't mysterious AI failures. They're standard development challenges that we debugged methodically using our documentation as reference. The structured approach made these problems manageable instead of mysterious black box failures. Crucial part of our approach was creating comprehensive testing documentation. We built testingguide.md with specific test cases and expected results. Basic orders, like 1 large cappuccino with oat milk, should return exactly $4.88 total. Fuzzy matching tests like one large cap with oat milk should correctly identify cap as cappuccino. Error cases like one espresso should return helpful menu suggestions, not technical errors. We included edge cases for extra spaces, special characters, and case sensitivity. Each test case specifies the exact expected response format, including HTML markup and emoji structure. This isn't just functional testing. It's verification that AI-generated code handles real-world user input correctly. After each task implementation, we follow a thorough verification process. We run all test cases from testing.md to ensure functionality works correctly. We manually test in the actual Telegram app because automated tests can miss platform-specific behavior. We answer quiz questions about implementation details like middleware order. We document any additional requirements discovered during testing. Only after completing all verification steps do we check the progress box and move to the next task. Building on unverified code is how you end up with systems that work initially but become impossible to maintain or modify. Here's a concrete example of why context quality matters. We were having persistent problems with Telegraf Webhook implementation. The AI kept generating webhook code that looked correct, but didn't function properly. The issue was that the AI's training data contained outdated Telegraf documentation patterns. We solved this by using Context7, an MCP server that provides current library documentation to AI tools. Once the AI had access to proper Telegraf documentation, it generated the correct implementation immediately. This demonstrates that AI assistance quality depends heavily on the context and documentation you provide. Throughout this process, we carefully documented everything in implementation progress.md. Technical decisions and their rationale. Use Telegraf framework for TypeScript support and middleware patterns. Problems encountered and solutions. Webhook issues required express server with bot. Webhook callback method. Timeline with actual dates. Task 1 completed 2025, 7/22, after resolving webhook configuration. We also required AI to document its implementation choices through detailed reports explaining architectural decisions, dependencies, and limitations. This documentation becomes invaluable for future maintenance, team onboarding, and system modifications. What we ended up with is a working system plus comprehensive process documentation. The repository contains 600 lines of production-ready TypeScript code, foundation documents that guided every AI decision, progress tracking with real problems documented, quiz questions that ensure understanding, and verification checklists for each task. The process documentation is as valuable as the final code because it enables future modifications, team adoption, and expansion to other platforms. Without comprehensive documentation, you have working code, but no understanding of why it works or how to change it safely. Structured verification enables conversational coding to work reliably. LMS make the same mistakes as human developers. So you debug them methodically using your documentation as reference. But you must verify each step before building on it, and quiz questions ensure you maintain architectural control. Conversational coding works when you maintain control through comprehensive context and continuous verification. Without this control, you get working code that becomes unmaintainable technical debt. The complete process is documented at GitHub. Study the foundation documents that enabled AI success, the specific user stories, data models, and implementation tasks. Examine an implementation progress.md to see our real timeline with actual problems and solutions. Look at the task verification checklists and quiz questions. Review bot.ts to see the quality of AI-generated implementation when provided with comprehensive context. Most importantly, study the step-by-step progression from empty folder to working system with verification at every step. Let me give you the real-time breakdown for this project so you can set realistic expectations. Writing the foundation documentation took about 30 minutes. Not a huge upfront investment. The initial coding with AI assistance, plus answering quiz questions, took 45 to 60 minutes. Then, I spent 2 hours wrestling with deployment, but I should mention I'm a terrible system administrator, so that was probably longer than necessary. Debugging and fixes took another 1 to 2 hours, though this could have been faster with better systematic debugging practices. Total time was roughly 3 to 4 hours for a working, deployed system that handles real user scenarios. Here's the important context. I had very little experience with Telegraf and had never created Telegram webhooks before. The systematic documentation approach combined with AI assistance effectively bridged those knowledge gaps. Without proper context documentation, trying to learn Telegraf while building a working system would have taken much longer or resulted in unmaintainable code. The key insight is that the front-loaded documentation actually saves time in the debugging phase. Instead of random troubleshooting, you have clear specifications to verify against and systematic checklists to identify exactly where things went wrong. The key learning philosophy here is start thorough, and speed will come later. When you're learning any new tool, whether it's a musical instrument, a programming framework, or AI-assisted development, you need to build competency through structured practice before trying to optimize for velocity. Begin with small projects where you can focus on building verification habits without time pressure. Master the documentation approach and understand how each component enables AI success. Build your competency with clear examples like this coffee bot before applying the methodology to complex enterprise systems. In upcoming presentations, we'll dive deep into each component. How to write user scenarios that actually drive effective AI assistance instead of generic solutions. How to create implementation tasks with proper verification that catch problems before they compound. How to handle AI mistakes methodically without losing architectural control. The process that actually works is this. Document requirements comprehensively before any AI interaction. Break work into verifiable tasks with quiz questions ensuring understanding. Use AI with comprehensive context. Verify thoroughly before building on results. And document all decisions and problems for future reference. AI accelerates development when you maintain architectural control through comprehensive documentation and verification. It's not about replacing human judgment. It's about amplifying human capability through structured preparation and continuous quality control. I'm curious about your current verification approaches. How do you verify AI-generated code quality before building on top of it? What documentation approaches have worked or failed for your projects? How do you maintain understanding of AI implementations as they grow in complexity? What structured approaches have you tried, and where did they break down? Share your experiences with maintaining control over AI-assisted development. The goal is building practical understanding of approaches that work in real development scenarios with real-time pressures. The complete repository is available in the video links. The next presentations will go deeper into each documentation component. Focus on building structured habits with small projects first, then applying them to larger challenges as your competency grows. The methodology scales, but the foundation is comprehensive documentation and verification at every step.